morning, everyone. My name is Hunter Thielen, and I'm presenting on my Econ 3 and 4 project, subsidized housing and whether it negatively influences residential property values. So I'm going to go over my outline for my presentation. I will start with a literature review where I will discuss the key findings from my literature. I will then follow a theoretical framework discussing the theory behind my models, and then I will follow with an empirical framework followed by data, and then an empirical analysis, and my results followed by a conclusion. So a little background: there are over 2 million households assisted by subsidized housing. On average, 30% of people's income goes towards housing, and minimum wage workers cannot afford housing on their own with the wage given to them. Types of subsidized housing that I examined in this project: the HUD Section 202 program, the Section 8 housing program, the public housing program, and the low-income housing tax credit. So key literature: the first article I examined was Santiago, Galster, and Tation. They found that subsidized housing had a positive effect on family home values in the area. However, later findings revealed that proximity to public housing sites in black neighborhoods caused slower growth in home sale prices compared to other neighborhoods. Next article, Galster, Tation, and Pettit, 2004, examined housing in the Denver area. Using a difference in difference regression, they determined that the development of supportive housing was not associated with any negative impacts on housing prices within 500 feet of their locations. However, homes within the 1,000 to 2,000 feet, in some cases, were reported as experiencing increased home values. And then my next article, Ellen, Vossi, and Schill, they studied homes in New York and determined that in most cases there isn't enough empirical evidence to support that federal housing programs negatively affect local home values. They also determined that small public housing projects for elderly individuals increase property values over time. My literature was really ambiguous. Results were hard to determine. In a lot of cases, the findings found that most people didn't experience any difference in their home values when being in proximity to subsidized housing. Onto my theoretical framework. This model comes from Sherwin-Rosen, 1974. And basically it's a utility function. Price is on the y-axis and distance from apartments is on the x-axis. Now, it's important to note that my data did not provide subsidized housing in the data set. So I had to substitute subsidized housing for apartment housing on the assumption that apartment housing has some form of subsidized housing in it. And what this model states, it shows the curve labeled WTA shows an individual's willingness to accept at a given price, and the curve labeled WTP is their willingness to pay at a given price. And where they intersect is the equilibrium that is met. We see that homes that are located closer to apartments have a lower value than homes located farther to apartments. And that's just basically the theory behind it. Another model I have is just a supply and demand curve with price being on the y-axis and quantity of homes being on the x-axis. And basically this assumes that individuals who prefer not to live near subsidized housing due to fear of things like increased crime, substance abuse, violence, or the potential for their home to devalue, basically it causes the demand to shift inward from D1 to D2, causing the price to fall from P1 to P2. So here's my empirical framework. This is my functional form. I'm attempting to estimate housing price as a function of bathrooms, bedrooms, dining rooms, family rooms, half bathrooms, kitchens, living rooms, h squared, the natural log of lot size, the natural log of unit square footage, air systems, which is like air conditioning, which is a dummy variable, garage, which is a dummy variable, and nearby apartment housing, which is a dummy variable. And then the final is a geographical location variable at an SMSA variable. Basically, it just accounts for the different locations in the U.S. Yeah. So my key important estimated signs for this project. Unit square footage is expected to be positive. Bedrooms and bathrooms are both expected to be positive. Lot size is expected to be positive. Age is expected to be negative. Nearby apartment housing is expected to be negative. Like I said, nearby apartment housing is substituted for subsidized housing because it was not provided in the data set. My data comes from the 2013 American Housing Survey conducted by the U.S. Census Bureau. Initially, there was over 40,000 observations for my data set. I eliminated over 31,000 due to not providing the home value or not providing the whether or not they were located nearby to an apartment housing. And as I stated before, subsidized housing was not provided in the data set, so I had to substitute apartment housing. Here, figure 3 is just the average value of all the homes located nearby apartment housing. And basically what this shows is that homes located nearby to apartment housing actually have a higher value than homes that are not located by apartment housing. So it's actually counterintuitive to what I had initially thought. However, if you look at figure 4, once it's blown up, the difference really isn't that noticeable overall. In my empirical results, like I said, there was 8,320 homes observed for this. The first thing to analyze is the p-value for the f-test. This determines if the model is significant or not. Because the p-value of the f-test is 0.00, we can reject the null, and the model is stated as being statistically significant and therefore has some explanatory power. The next thing to examine is the coefficient of determination, or the R-squared, which is 0.4772. This states that 47.72% of the variation in home value is explained by the listed independent variables. So the most important variables for estimating home price after running my regressions is bathrooms, family rooms, half baths, the natural log of unit square footage, garage, and then the nearby apartment housing. Looking at their p-values, we see that they are significant for all of them except for nearby apartment housing and the living room variable. Talk a little bit about my coefficients. Unit square footage had an estimated positive sign, and it turned out that the coefficient was positive at 0.256. What this means is a 1% increase in square footage leads to a 0.256 increase in the value of a home, holding all other things constant. Bedrooms and bathrooms both had estimated positive signs, and their coefficients turned out to be positive. H had an estimated negative sign, and it turned out to be negative, which is good to see. Nearby apartment housing had an estimated negative sign, and it turned out that the coefficient was negative, although it's not statistically significant because the p-value is 0.773. So all my expected signs agreed with my coefficients. Here is my counterfactual analysis. This is the exponentiated sum of my coefficients times their mean in order to determine the average home value. So we see that in this instance, homes located nearby to apartments actually have a lower value than homes that are not located by nearby apartments. However, it changes with the lower and upper bound coefficients. But like I said, it's shown by figure 6. Once you blow it up again, the difference really isn't that noticeable. So kind of ambiguous results there again. And my conclusion, initial data findings revealed that homes located nearby to apartment housing had a higher value than those that didn't. My literature had rather ambiguous results. My empirical results showed nearby apartment housing has a negative coefficient, although it wasn't statistically significant. And my counterfactual analysis revealed ambiguous results as well. So I don't think it's safe to say that subsidized housing, i.e. apartment housing, has a negative effect on home values overall. And then, like I said, the limitations in my data were the fact that I couldn't find subsidized housing, so I had to substitute apartment housing. Question?
I may have spaced on this. What was the geographical scope you were looking at here?
The U.S.
Okay. And were you looking at, you had how many observations?
8,320.
Okay. Thanks.
There was over 40,000, but
Yeah.
they didn't provide the value of the home, or they didn't provide whether they were located nearby to apartment housing, so that
Yes.
eliminated quite a bit.
Yeah. Thanks.
First of all, great job. My question is, what is one thing that you learned that you think is really interesting from doing this project?
I guess all the different variables that go into a home value, I guess. I don't know.
Anybody else?